We're now going to work with horizontal shifts and graphing of periodic functions. And horizontal shifts or horizontal translations are also called phase shifts. And something that's really, really important that helps me to figure out, or has found to be the most effective way of graphing horizontal translations, is that the fact that these horizontal translations don't affect the period, the amplitude, or our equilibrium or our mean position. So the way that I do this and the way that I make the fewest errors is I graph the graph without a horizontal translation, just with a dotted line, and then I do the shift. Let me show you what I mean. So it says, sketch the graph of y equals -3 cos of 4x minus pi on 3. So the first thing we need to do is get it into our correct form, because you'll notice here I've got a 4x, I need to get x naked. So in the form y is a cos b of x minus c plus d, I'm going to have y equals -3 cos of 4 x minus pi on 12 plus 5. Okay, now let's go through as we normally would. We got that our absolute value of a is going to be 3. That means that my amplitude is equal to 3. But at the same time, my amplitude is negative, so a is less than 0, therefore it is reflected in the x-axis. This is a cos graph, so that means I'm expecting it to start below my mean position. Okay, I know that my b value is equal to 4, and I also know then that my period is 2 pi on b, so that means it's going to be 2 pi on 4, which is pi on 2. Alright, now remember our period helps us to find our x-axis divisions, so my x-axis divisions has to be pi on 2 divided by 4, which is going to be pi on 8. Hold that thought. Okay, now we have a phase shift of pi on 12 to the right. Okay, and now this is going to affect our x-axis divisions. Okay, so with phase shift, we need to be able to work with a pi on 8 plus a pi on 12. Therefore, we need the lowest common denominator of them. Okay, so my x-axis divisions are actually going to be pi on 24. That way, I will easily be able to shift. Okay, my d value is equal to 5. That's my mean value, or my mean position at y equals 5, and that helps me to know what my range is. So my range will be 5 minus 3 to 5 plus 3. And we've been given a domain of 0 to pi. Okay, now we can start with our x-intercepts. I know it's going from 2 to 8, so there are no x-intercepts. My y-intercept happens when x equals 0, so I have y equals -3 cos of 4 times -pi on 12 plus 5. That gives me -3 cos of -pi on 3 plus 5, and cos of negative pi on 3, remember, we have CAST, negative pi on 3 is in quadrant 4, cos is positive in quadrant 4, and cos of pi on 3, let's draw a triangle, is going to be a half. Okay, so I've got negative 3 times positive a half plus 5, and that value is going to be 7 on 2. So y is going to be 7 on 2. I also need to know what's happening at the endpoint of my domain. And that's going to be when x equals pi. Okay, so I'll have y equals negative 3 cos of 4 pi minus pi on 12 plus 5. And again, that's going to give me minus 4 cos of 11 pi on 12 times 4 gives me 11 pi on 3. And 11 pi on 3 is 3, 6, 9, 12. So that's the same as 12 pi minus pi on 3. And that's the same as 2 pi minus pi on 3, which becomes cos of negative pi on 3 plus 5. And as we've seen already, that's also equal to 7 on 2. So at pi, 7 on 2 is where my x-axis, where my graph ends. All right, I've already done the divisions because otherwise I would take too long to do them. And you'll see I've got pi on 24 over here. Now, it can look very, very messy and busy, so I wouldn't mark every single one of them. I know that 24 pi on 24 will give me pi. 12 pi on 24, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, will be my pi on 2. Okay, or 4 pi on 8. Remember, my pi on 8s were actually what I was looking for. So every 3 will be a pi on 8. And maybe those are sufficient to draw in terms of labels or scaling. Okay, so 4 pi on 8, 5 pi on 8, 6 pi on 8, and 7 pi on 8. That looks quite neat, and that works fine. I'm wanting to go from 2 to 8, so 0, 2, 4, 6, 8, and my mean position's at 5, so I'm going to draw in my mean position. I think I'm going to need to move this up slightly. Just going to move that. It wasn't 0, it was a pi. Okay, that should be able to fit in. Alrighty, now I'm going to draw 2 graphs. Okay, I'm going to draw an unshifted graph. Okay, and I'm going to do that in a dotted line, but I'll do it in blue just to show you. Alright, so if the graph was just negative 3 cos of 4x plus 5. Okay, so this is the one I'm sketching first. Okay, I know that I'm going to be starting at 2. Okay, and my period is pi on 2. So I know that at pi on 2, I'm going to reach 2 again. and at pi I'm going to reach 2 again. This is a cos graph, a negative cos graph, that's why I'm starting down at the bottom. Okay, but then halfway I know that I'm going to be at the top of my cycle. So at 2 pi on 8, or pi on 4, I'm going to be up at the top of my cycle, and at 6 pi on 8 I'll be up at the top of my cycle. I will be crossing my mean value at pi on 8, 3 pi on 8, 5 pi on 8, and 7 pi on 8. Okay, so far nothing new. It is just a standard negative cos graph with a period of pi on 2. So you sketch this, and then you are going to shift every single point that you have marked pi on 12 to the right. And it is as easy as this because you have marked all of these. Okay, so all you're going to do is, remember that's pi on 24, there's pi on 12, so I'm going to shift 2 spaces over to the right. So every single point just moves 2 spaces over. Alright, now you'll notice I'm not going to have a starting point at 2 anymore, but luckily I've worked out my starting point was at 7 over 2, which is 3.5. So at 3.5, that point over there is going to be 0, 7 over 2. And remember, we worked out again at pi, I would have the same value. So that's going to be at pi and 7 over 2. Alright, now what we're going to do is we're going to sketch this graph. And there it is. Y equals negative 3 cos of 4x minus pi on 3 plus 5. We also need to label our points, so we're going to have pi on 12 and 2. We're going to have 8 pi on 24 and 8. We're going to have 14 pi on 24 and 2. And we're going to have 20 pi on 24 and 8. Wonderful.